Hi students, good morning. Let's now we are going to discuss here charges and electric field. Charges and its electric field. Okay. Last class already we discussed interaction of forces between the two charges according to Coulomb's law. F is equal to K Q1 Q2 by R square. Last class already we discussed about this point, about this concept clearly about the charge. Already last class we discussed about it, the charge definition, basic information about the charges and the Coulomb's laws. Okay, students. Now we are going to discuss the electric field. What is electric field? Electric field. Electric field. Every charge create electric field around itself in the space. So every charge create electric field. Every charge create electric field around itself in the space. Around here. So let's know this. For example, positive charge is here. Positive charge create electric field around itself in the space. Radially outward direction. Radially outward direction. Radially outward direction. Electric field. Radially outward. In all directions. In all directions in the space. Electric field create. So positive charge create electric field radially outward direction. Radially outward direction. Okay, students. And as well as negative charges, what is that? Negative charges. Negative charge is radially inward. Radially inward. Okay, radially inward. Now observe here, this is radially inward. So radially inward direction. So this is charges create electric field around itself. Okay, students. Positive charges radially outward and negative charges radially inwards. Clear? Last we are going to discuss here the electric field. Find the electric field intensity due to a point charge. Okay, next. Right now here, find here the electric field intensity. Electric field intensity due to a point charge. So we are going to this concept is here. Electric field due to a point charge. Electric field due to a point charge. Okay, right now. How can you find this electric field due to a point charge? Okay, take here one of the charges, take a positive charge. Take a positive charge. From this positive charge or distance, take at one point at P. To find the electric field intensity due to this point charge at P point. Okay, so electric field due to this point charge, from all distance, P point. Electric field. Find electric field due to this point charge at P. Okay, students. So how can you find this electric field at this P point? So generally we take here this one of this test charge. Q naught. This is one of the test charge placed here. Assumption. We take the test charge at P point. Okay, students. Test charge placing the test charge at P point. So when we find electric field, first you already find the electric field, force on test charge, by test charge. So now the formula. So generally right now electric field E ball is equal to force on test charge by test charge. So by help of this here, you observe carefully E F by Q naught. So right now we are finding. So E is the electric field at this P point is equal to force between these two charges. What is the electric force according to Coulomb's law already we discussed here. So force between the plus Q charge, test charge is here. Electric force between them K, Q naught by R square. By test charge, what is the test charge here? Q. We cancel each other, Q naught, when we get answer. Electric field at this P point K, Q by R square. This is a very important electric field due to the point charge at a distance R, KQ by R square. KQ by R square. KQ by R square. Okay, students. Electric field intensity or electric field intensity due to a point charges at a distance R at P point. Electric field intensity at P point KQ by R square. KQ by R square. Okay, students. Next here we are going to discuss about here this small questions is there. So how can you find the electric field intensity? Okay, right here. This is a formula to find the point due to point charge at P point KQ by R square. Very important points is here. Next concept is here. Next is how do you find the electric field? In a system of charges. In a system of charges. Let's know here. So take a equilateral triangle. Okay? Equilateral triangle. We arrange at vertex A, B, C. At A point, B point we arrange here this plus Q charge. And C point we arrange in the minus Q charge. Find the electric field intensity. Find electric field intensity. Electric field intensity at C point. At A point. Find net electric field intensity. Find the net electric field intensity at A point. Due to these two charges, how can you find it? So already we learned what is that here? Due to this point electric field formula already E is equal to KQ by R square. Already we discussed about this one. Okay, students. Due to this Q charge, electric field is at A point. What is it? This is equilateral triangle. That's why distance A, equal distance is there. And angles also is 60 degree, equilateral triangle 60 degree. This is also 60 degree. This also is 60 degree. So due to this plus Q charge at A point, electric field intensity radially outward. Radially outward. Electric field EA. Due to this plus Q charge. And next, due to this minus Q charge, electric field at A point radially inward. So due to this at A point. So electric field at A point due to B. Electric field at A point due to C. Okay, students. So electric field intensity at A point due to B E is equal to, how can you write this? K Q by R square. What is the distance between here? What is the distance at this point and this Q charge? A square. Question number 1. So, as well as similarly, electric field at A point due to minus Q charge at C. So, how can you write this here? At due to A, C. So, how can you write K Q by distance between then A square equation? Okay, students. Both are same charge, same electric field intensity acts on the A point. That's why we write now here. This is both are same electric field. Assumption both are same E and P. So you observe here. What is the angle between this? So what is the angle here? Observe here. Total angle is straight line is here. Total 180 degrees. When we remove the 60 degree, remaining what is that here? 120 degree. So in the electric field intensity between the angles 120 degree. When you apply here this, what is the net electric field intensity? This is net electric field intensity, E net. Is it net electric field intensity? When you find the net electric field intensity, E net is equal to root of E square plus E square plus 2 into E into cos 120 degree. This is vector form. This is a net find here. So finally, how do we write this here? So E net is equal to root of E square plus E square 2E square plus 2E square cos 120 minus 1 by 2 minus, what is the value of the cos 120? What is the value of cos 120? Minus 1 by 2. So right now here 2 will get cancelled. Then you get answer net electric field intensity. Therefore E net is equal to root of 2E square plus into minus E square. Minus E square is there. So next is here net electric field. So we write here 2E square minus E square, then you get the E square. Okay students, when you cancel root and square cancel each other, then you get the what is that? E net is equal to E. What is the E value? We find here what is the E value is there? KQ by A square. That is E net is equal to what is it? KQ by, finally we write down here. E net electric field intensity at A point K Q by A square. This is net electric field acts at A point due to these two charges. Okay students, this is a simple formula by help of this electric field intensity. How can you find the electric field intensity in the system of charges? By help of the superposition process also we apply here and electric field intensity formula apply. So then you get the answer E net is equal to KQ by A square. Okay students? Okay, next class we will discuss another problems. Bye.